We're going to do a session now on tax and finance. These are the questions in the number side that are practical for those in employment and working about tax and VAT and profit, etc. So we'll start now with a few basics on income tax. In income tax, a few notes to take into account. Income tax is a percentage of gross income. So you might have 20% income tax, 30% income tax, and it's on the total income. And then tax credits reduce this amount. So if you have entitlements, after you do the percentage, you get your tax credits. So here's a question where you're given information on the standard tax rate, the standard rate cut off and tax credit, and you're asked to calculate the tax due. So it sounds a lot, but it's actually reasonably simple in the question format. Imagine that John is taxed at 20%. His salary is $450 per week, and with tax credits of $53 per week, calculate his weekly tax liability. So you're told here that he's got 20% tax, he's $450 a week, and he's $53 a week credits that he doesn't have to pay tax. So his tax bill will be reduced by that amount. So the first thing you've got to accept is that all of the $450 is going to be subject to the 20%. So looking at the calculations, we say that the gross pay is $450 per week. Now we have to now say that 20% of that is going to go on tax. Now we can get the 20% in lots of ways. We can say 100% is $450, 20% is what? We can work out what that calculation is, plug it in the calculator, it's a fifth. 20 is to 100 as a fifth is to that. So we find that the tax now, his tax bill is 90. But also we're told that you're allowed certain credits. So the first €53 in tax he doesn't have to pay. So 53 is his tax credit. So his total liability then is the 90 minus the 53 or €37. So we have €37 now to pay in tax. But what was his net pay? Well, he was getting $450 a week, so $450 was what he was being paid. 37 is what his tax bill is. So $450 minus 37 is $413 a week. So we've we've estimated John's entitlement to take-home pay from his $450 salary. So let's move on from that. John gets promoted at work, he's doing a very good job, and his salary moves up. He's on $450 a week, and he had a tax credit of 53 and a tax rate of 20%. Exactly. But his salary has now moved to €600 per week. Now with that, he's got a new tax credit of 153, but his tax rate has gone to 40. So the question is, how much more money does he receive each week? Now, he'll get some more, but lots of things have changed. So effectively what we've got to do is you've got to look at the original position and the new position. And the original position really was the 450, the 53 and the 20. We've done that. We're saying that the gross pay was 450, then the 20%, and we had worked that out as 413 a week. So that's the original calculation. But now let's look at the new position. Well, the new position now, shown in red, really is that he's got a salary of 600 a week, so that's quite a bit. He's got 153 as the tax credits, which will help, but he's got a tax rate of 40%. So it's exactly the same format, but just different numbers. So the gross pay in the second occasion is 600 a week. The tax is 40%, so all of the 600 is hit at the 40%. So again, we could imagine here a grid, and we say if 100% is €600, what's 40%? Or we work it out in whatever way we use the calculator on that, but we multiply by the percentage, and we say the tax now due is $240. But with the tax bill, you also have a tax credit and allowance. And on this occasion, this was now 153. So we're now looking at his 240 minus 153, and that's his tax bill. And that turns out to be 87 a week. But he's earning 600 a week. 600 minus 87, it's 513 a week is his new salary. And if we compare that to his old one, he was earning 413 a week here in blue, now 513. So his increased salary, one minus the other, he's up €100 a week. Now, remember that his official salary, his gross salary, went from 450 to 600, which was a total of 150 increase, but his take-home pay after that is 100. So you can see all those things coming together. So we're going to do a different example now. We're still going to stay with John, and we're going to start again with the same original. He had 450 originally. He had a tax credit of 53 and a rate of 20. But on this occasion, we're saying his salary has been increased. We're not saying by how much. We're saying that he's got a tax credit of 153. His tax rate is 40%. We actually don't know what his salary, we don't know that it's 600 or 700 or whatever. We're not sure. We're actually being told here, though, that he's €90 better off than he was. So how do we solve that one now? So let's look at what we do know. Well, we know that his old gross salary, we could work out all those things. We could work out the original, etc. So the original position is exactly as before. The original position is that he had 450 a week, 20%, 90, etc. The same 413 as before. So nothing changes on that. But let's look at the second one. The second one is, we have this thing now, and it's 153, we know the credit, we know the 40%, we know the 90, etc., but we don't know the amount. And if we don't know the amount, the best way to do that is say, well, let's call it X. We don't know what the gross salary is. So let's assume that the gross pay, let's just say it's X a week. We don't know what it is. We do know some things about it. If the gross pay is X a week, we know that when it was 600 a week, we went to 40%. We know that the tax is 40%. So if 100% of a salary is X, what's 40% in terms of the tax? You have to work out what that number is. And that turns out to be 0.4X, 40%. Now, we're in the bracket here that he's on the higher rate at 40%, and he gets a tax credit of 153. So even if his tax is 0.4x, he'll actually be allowed to reduce that. So his overall tax liability is going to be 0.4x minus the 153 credit. So he's not as badly off as he was before the credit. Now, what does that mean about his salary, though? Well, this is just the tax liability. That's the amount of what tax he's got to pay. But his salary is still X. We were told that that's his salary, gross salary. So the gross salary minus his tax should give us his take-home pay. So the new net pay is the new pay minus the tax liability, or the X minus this 0.4 minus the 153. So we do some slow work on that there. We're saying that the new net pay is X minus, and we have it here, 0.4, all in brackets now, 0.4x minus 153. Now, putting the bracket in and distributing it all the way across, we get x minus 0.4x, and minus by minus is plus 153. We don't have to put in the euro sign because the euro sign applies really to it all, so we could sort of leave that out. Now, x minus 0.4x is really 1x minus 0.4x plus 153. And 1 minus 0.4 is 0.6x plus 153. So this is his now new take-home pay. He was getting x. This is the amount of tax he's due. And the reason there's a plus there is his tax credit is back. So this is his new pay. New, let's call it the new, well, it is the new net pay. So he's got 0.6 plus 153. But what was the question? Yeah, the question says that his new net pay was €90 better than the old pay. So the new is old plus 90. So that's the equation we're looking at. Well, the old was the very first there, the 450, and that was 400 and, let's go back, it's 413 plus the 90. Or we add those up together, it's 503. So his new salary is 503. But from a formula point of view, his new salary is 0.6x plus 153. And now we've got a single equation in x with two values, two numbers there that we can resolve. So let's just tidy this up. We might say 0.6x is equal to 503, and we'll take this 153 over to the other side, minus 153. Or 0.6x is equal to, subtracting those, we get 350. So looking at that equation now, we say that the new net pay is 413, the old, plus the 90, the 503. Here was the equation that we equated, and we found that x, 0.6x, is 350. Well, to solve that then, if 0.6x is 350, what's x? Well, we just divide this side by 0.6, and we divide this side by 0.6. So x is equal to 350 divided by 0.6. So if we look at that here, x is 350 over 0.6. That on a calculator turns out to be €583.33. Now, that's not surprising in a way, because in the previous question, when John's salary went to €600, he was €100 better off. On this occasion, it hasn't quite gone to 600, so it's less, and he's only €90 off. So it's pretty much the same. So you get the idea. It's in the ballpark. It looks right. In fact, the calculations are right. We turn now to a different topic, no longer about personal tax or anything like that. But we're talking about buying and selling items for profit. There might be VAT as well, value-added tax as well. So let's look at the basic equation. The basic equation in business, when you're buying and selling, is that profit is regarded as the revenue or the sales minus the costs. So if you buy something for €10 and sell it on for 12, well, your costs are basically your 10 for buying it. Your 12 is your revenue. The difference then would be 2. You're on that profit difference. VAT is a tax, and it's paid on sales. Unless you're told otherwise, it will be in the sale price to the consumer. So here's a question now. We're looking at a question where an exporter buys a product for $12.25 and requires a profit of 40%. If VAT is charged at 21%, what's the selling price? Now, there's an awful lot going on there. So we better just might be useful just to take some time out and see if we can work out the steps. You buy something for $12.25. You want a profit of 40, and there's VAT on top of that again. Well, actually, the profit is what you're looking for. The VAT we can put on later, so we can do this in 2 steps. So what you're saying is that it's $12.25 to buy this. And we want to sell this. We don't know the price we're going to sell it at. We don't know. But we want 40% extra. If we want 40% extra, another way of looking at that is we want it to go from 100% to 140%. Or we might just say get 40% and add it to the original number. So one way of doing this, if we were saying, if the original price, $12.25, represented 100%, and you wanted to move that to 140%, what would this number then be? So 100% is to 12.25, as 140% is to what? And we can find that out through crisscrossing in some way. We can work out the calculations. And we can say, let's call that number x. So 100 times x is equal to 12.25 times 140. X is equal to 12.25 times 140 divided by 100. Now this number is going to turn out to be bigger than 12.25. And that's not surprising because we want a good profit on it. And we can work that out on the calculator. This is just one method. And we'll return to this number because the numbers will be the same. Let's look at it another way and say, okay, it was 12.25 for the item, and that was 100%. We want 40% profit. Well, if 100% is 12.25, what's 40%? And we can work that calculation out too. So call this x2 maybe. So 100 times x2 is equal to 12.25 times 40. So 100x2 is equal to 4 by 12. That looks like it's 500. That's wrong. Sorry, I just catch that again. Sorry, I just shouldn't have done this off the top of my head. I'll take it from about, where was I on that? I'll do it from that slide. Is that okay? Another way of doing this is to say 12.25 was the original purchase price. That was 100%. If we want a 40% profit, we'll say, what's 40% of it? So we want to know what that number is. So we can call this number x2, for example. And we say 100 times x2 is equal to 40 times 12.125. And if you take 40 times 12.125, you get 490. 490 is the profit you want. So 12.25 was the original price. 490 is the profit. And you can add those two together. And adding those two together, you get 17.15. If we went back and we did it this way, 12.25 x 100 and 140, done the calculations, we would have got 17.15. So either way, where we're looking at 140% of something, or 40% that we add on, basically we're looking at 17.15 required to make the profit we're looking for. Now, that was only the first part of the question, because it said, that's the profit I wanted 40%. But also, the customer then who buys it will have to have an additional charge of 21% VAT. So what we do here is we say, well, the selling price has to include VAT. The selling price excluding VAT is 17.15. VAT is 21%. So there's two ways of doing this. We can say 17.15 plus 21% of 17.15 and find out what that answer is. Or we can say, what's 121% of 17.15? Either way, the number is going to increase, and we find that the answer is €20.75 when we multiply. In one case here, we're adding 21% to 17.15. 100% is 17.15. What's 21%? If we do the calculations, 21% of that, we find it's 360. So 360 is the VAT cost on top of the other. The total cost is 20.75. Quite a markup, really, from where we started with the original part of that question. Now, let's look at some examples now of customers and consumers buying products. Cost, sales, price We're going to take example 1, and we're going to look at Louise. Louise's business here, she wishes to sell a particular product to customers at a price of $19.99. You see this a lot of times in the shops. Everybody wants to pitch something at a particular price, and there's something psychological about the under €20 mark, so we're talking about exactly $19.99. Now, because it's being sold for that, and VAT is included in it, the VAT of 13% is in that price. So that already has VAT in it. If Louise wants to make 35% profit, then what does she have to buy this item for? So let's look at the picture. It's selling for $19.99. That's the sale price. That's with VAT. What's the sale price minus the VAT? It's going to be less. And then if that turns out to be with the profit, what was the actual purchase or the cost price? So let's go through it. Well, the selling price was $19.99. We're told that. We're also told that the VAT rate is 13. So if the VAT rate is 13, we've already added the number in it. So whatever the price was as 100% got 13% added to it. So it's now 113% of the original price before the VAT, and that's what's equal to $19.99. And to get things back in order, we've got to say, well, if 113% of the overall is now $19.99, what's 100? And we can work that out with the cross multiplication method. That is 113 times x is 19.9 times 100. 113x is equal to 1999. X is equal to 1999 over 113. Now, if we work that out on a calculator, what do we expect it to be? Well, this is smaller than this, so this number should be smaller than that as we look up. So if 113% is nearly €20, 100 would be less. Equally, as we move across here, this tells us that 113 gives us 20. This will give us less. So if we look at the calculator and plug the numbers in, we can find that the answer we get is 17.69. Here we see the multiplication out in full. All the various tabulations there. We see there was the total given. You were told 113% of the price was $19.99 because the VAT was in. Stripping out the VAT, you want to say, what would it be with just the 100 without the VAT? The crisscrossing, doing the calculations, X is 17.69. And again, if we go back to the question, that's only a part of it. Because having taken the VAT out, we haven't addressed the issue of profit. If you go back to example 1, it says the selling price, we want it to be, without the VAT, we wanted that to be the purchase price plus 35%. We wanted another 35%. So effectively what we're saying is that if I take the purchase price plus 35% of it, because that's what I want, that has to now equal what we got of the 1769. But the purchase price plus 35% of the purchase price is 100% of the purchase price plus that. Or overall, 135% of the purchase price is that. So if that's 135%, what's 100? And again, we can do that using the tabular method. We can say the selling price is 135% of the purchase price. We now want to calculate before the 35. So 135% gave us 1769. What will 100 give us? Over here. Again, in a 2 by 2, we say 113 is to 1769 as 100 is to what? Reading horizontally. Now we crisscross the multiplications and we say 17.69 times 100 is 113 times x. So we do it there. So that's how we do the calculations. 130. So we're looking here about, there we see it, 135 times x is 17.6 times this. So 135 times x is 100 times this. X is 1769 over that, 13.10. So Louise must buy the product at 13.10. 13.10, and remember, she's selling it. The profit brings it up nicely to 1769, and the VAT brings it up to 19.99. So we see the VAT here and the profit here. We now turn to the last part of the finance section, and that's the section to do with investments. And typically what's happening here is that you get a series of investments over a period of time. 1 year to the second, to the third, to the fourth. And over time, when you invest money in a bank or in some investment fund, a financial fund, you expect that investment to grow. The numbers, if you leave money on deposit, the €100 might become 103 or 104 at the end of a year. There'll be some multiplying effect. Equally, if you want €100 in a year's time, you don't need 100 just now. You could put in a bit less, maybe 96, 97, and the interest and the multiplication and the added value would bring it up to 100. So as we move on in time, the numbers get bigger if we leave money in. As we come back in time, we don't need as much if we're going to have money requirements in the future, and we can plan for them now. So let's look at the way these things are done. These are all based around a fairly standard model of compound interest. And they say where R is the annual interest rate, the annual compounding multiplicative factor can be expressed as I is equal to 1 plus R squared. Now that sounds maybe a bit convoluted, but let's look at that from a numbers point of view. It basically says that if you have an interest rate of 8%, this is a compounding factor of 1 plus 8% or 108 or 1.08. Much more simply, it's saying that if you have €100 and it's at 8%, 8% of this, 8% of 100 is 8. You add it and you end up with 108. So you can see that as the R value here of 8%. But really, if you think about it, how do you get from 100 to 108? Well, you multiply by something. And 108 divided by 100 is 1.08. So effectively what we're doing is we're multiplying by 1.08. And this 1.08 is the 1 plus the interest rate here that they're talking about. So they're saying is, going to start this again. Sorry, I've used INR the wrong way. Going to have to do this again. It was just the letters, that's all. It's a pity. I was enjoying it. Oh, I'm going to have a drink of water for a sec. Now. We're now going to look at investments in finance. And what's happening here is that it's to do with putting money aside, possibly for a retirement, pension or something like that, or an investment fund, where you put in money into the bank or some other financial agency, and you will leave it there over time and it grows. So it's both the time and the value of money. So here it says, when R is the annual interest rate, the annual compounding multiplicative factor can be expressed as I is equal to 1 plus R squared. Now that sounds like a lot, so we'll take that in sort of simpler English. Let's take an example where somebody puts money on deposit and they get an interest rate of 8%. What happens to that money over time? Well, let's start with €100, and let's say it grows to, this is now, and this is after 1 year. 1 year end. And this is a graph showing time. And we'll take time from left to right here. So we start off now, and years later we've got this. Now there may be other years that we'll talk about, year 2, year 3, etc. But for the moment, just take one period of 1 year. Now what we're saying is that we put this in at 8%. Well, if it's 8%, 8% of 100, given that 100 is the percent we're talking about, 8% of 100 is 8. So we keep our €100 and we get 8. So we get 100 plus 8 here. So effectively what has happened is that this has grown, it's multiplied. Now if 100 became 108, through a multiplication it says 100 times x is 108. 100x is 108. X is equal to 108 over 100. X is equal to 1.08. So effectively what we have is we've got this link that says that this times this multiplication going forward, multiply, from putting in money now and it getting bigger over the time is 1.08. That's the way you might write that is 1 plus the interest rate. So I, the compounding factor, is 1 plus or percent. 1 plus 8%, 108%, 1.08. I is equal to. So that's where we're getting that. That's our I, that's our or, and that's our calculation. So let's see if we can do a sum now. We have a question here where we're building a fund, and we're saying calculate the investment, the value of an investment of €100 after 4 years, if invested at the rate of 8% for the entire duration. Well, when I look at this question, the first thing I think about is, well, there's I suppose a few, but I look at the 4 years. That's really important. It's the time span. And I just draw the curtains. 1, 2, 3, 4 years. This is now year 1, 2, 3, year 4, and the end of year 4. So effectively what I have is I draw each year. Now, the end of year 1, year 2, year 3, and year 4. And I draw a link between them over time. Time is always moving from the left to the right. So here I have my 4. Now what did it say in the question? Oh, it said I have an investment of €100. Well, I'm only putting that in once. So I'll put that over in the now category. And it's growing at 8%. Well, 8% is or. And 8% gives us a compounding of 1.08. So 1.08, because we get our 8%, but we also get the 1, we get the 100 as well. So this becomes 108. If I then do 1.08 again, I use the calculator and I find that one. And again, and again. And as I'm moving from left to right, I'm always multiplying here because the money is getting bigger. So here you can see that I move from now 108, 116, 125, and 136. Each time I'm multiplying. The common link in this loop here is that under each one there's a multiplication by 1.08. And that tells me that at the end of the 4 years here, the answer is 136.05. And that's the fund. So let's take a second example now. This is the value of an investment of €1,500 after 6 years, where the interest, so 6 years is important. We're going to have 6 cycles in this question. The interest rate for the first 2 years is 5%. So that's an OR value of 5%. Not the compounding, but the OR. And the interest rate for the remaining is 6%. So we sort of have an OR1 and an OR2. So again, doing this rough hand, I'd say 6 years, I'd say 1, 2, 3, 4, 5, 6. This is now, and this is end year 6. Now it says here that the investment is 1,500. That looks like it goes there, and it's only entered once. There's no investment any other year, so it's just that one. The interest rate for the first 2 years is 5%. Now, if OR is 5%, I is equal to 1.05. So let's look at how we do this. Here we have year 1, year 2, all the way up to year 6. We've put in each of the loops. And what's happening? Well, the 1,500 for the first one has gone up. Now, we've used here 1.05. Why? Because for the first year 1, we said it was 5% or 1.05. Then 1.05. Because the question said, first 2 years is 5%. After that, it's 6. So they're all 1.06s. So if we look here, as we go from one to the other, 1.05, 1.05. We now multiply by 06, 06, 06, and 06. And chasing the original investment goes from 1,500 times this gives us 1,575. We go through each of the ones in turn until ultimately we end up with €2,087.82. And it's really cracked the same way. We look at the number of years first to give us the number of loops. 6 gives us 1, 2, 3, 4, 5, 6. One investment, so it's at the start. The rates then were 5% for 2 years and 6% for the other. And then after that, it's just plugging in the numbers. So let's look at the next question now. Let's look at retirement. Somebody is planning for their retirement, and it's very often that they will put money aside each year for that. Or maybe once, or maybe each year, or whatever. Now, let's look at Siobhan. Siobhan's situation is that she would like to retire in 4 years' time with a lump sum payment of 100,000. Now, she wants 100,000, not now. We don't know how much she's putting in, but we know that in 4 years' time, that's what she'll want. How much does she have to invest now at 4% to meet this requirement? It looks like she's putting in an investment now, but she's only doing it once. She's not going to do it every year, and she needs this in 4 years' time. So the 4 years will say 4 loops, that's for sure. The 100,000 she wants at the end. And the 4%. So how does that look then when we look at it? Well, here's now, and here's the end of year 4. And we've got 1, 2, 3, 4. But she wants 100,000 at the end, not at the beginning, but at the end. And she wants to figure out how much does she put in now, and that might be X. But to get 100,000, she doesn't need 100,000 just now because the numbers will be getting bigger. And we've always seen that as we move from one to the other, as we move forward, we multiply. But if we move back, we divide. So if this is increased by 4% as I go from year 3 to year 4, coming back from year 4 to year 3, I don't need as much. I divide by 1.04. So now I look at the 4 loops, 1, 2, 3, 4, but I'm coming back to say I'm putting in the money now. I only need it then. So 1, 2, 3, 4, and I'm dividing by 1.04. So I take the 100,000, divide again, divide again, divide again, and I get 800 or 85,480. Now, that's exactly the same as if we had said she's putting in 85,480. What will happen to it if she invests going forward in time? And we would say that would be multiplied, 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 multiplied to give us the 100,000. But we're looking back from the future back, so the number has got smaller. There's an alternative method there for that. We could have said, let the amount that we require be X. We could say, look, we don't know. We know she wants 100,000 here. We're going to call this X. And we know it's 4%. So therefore that's 1.04. So if we were to project forward or indeed back, we can equate. But let's go forward. We're saying that this X would become X times 1.04. times 1.04 times 1.04 times 1.04, and that would have to be equal to 100,000. Now this looks a bit long-winded. We could say x times 1.04 to the power of 4, because there's 1, 2, 3, 4 of them there, is equal to 100,000. Simplifying that, we could say, I don't like this stuff on the left-hand side, so I'm going to say x is equal to 100,000 divided by 1.04 to the 4. And really, this is just calculator stuff. That's a number, that's a number, that's a power. They're all on the calculator button. And if we press it, we find that we get 85480.42. Exactly the same as we got the alternative method. Here, we saw it was 854,480.42. So whether we do it this way or whether we do it with the compounding going forward, it's the same thing. So now let's look at Sorika's situation. Sorika wishes to retire in 3 years' time. And she wants 100,000 as well, but there's a bit of a difference here. Sorika is going to retire in 3 years. She wants 100,000. But she's willing to make investments, 3 equal investments, into an investment fund at the start of each year. And her fund is 7%. So this is more complicated. Basically, not only is she willing to put in money now, but she's going to do that for each of 3 years. So let's start with the diagram. The first thing we do in the diagram is 3. So we say 1, 2, 3. We want 100,000, that's now. So this is year 1, year 2, and year 3. Everything else is the same. This is time. So time is moving left to right. Sorika wants 100,000 at the end. And it's getting 7% per year. And 7% is R is 7%. So I there would be 1.07. So that would give us 1.07 here, here, and here. And because we're moving left to right, we'd say that's multiplication as we go forward, or division as we go back. But it's multiplication going forward. How much is her annual payment in the fund? Now, these are 3 equal payments. Well, we don't know. So when we don't know, the only thing we can say is, let's call it X. X is what she's going to put in there. But quite differently, she's also going to put in X here at the start of this year, the end of the first or the start of the second, and then the end of the second and the start of the third. That will also be gaining interest. So she has an X here going forward, an X here going forward, and an X here going forward. Now this becomes a little bit trickier, because that X is going to be multiplied by the percentage, and that's going to become, in its own right, 1.07 times X. But that's what would happen if she was putting nothing in the next year. She's going to put in another X on top of that. So she's going to have X and 1.07X. So 1X. So she's going to have 2.07X at the end of that year. And that's going to get moved along. So let's look at it in detail now. Here's the diagram. We have at the end of year 1, 2, and 3. So that's not surprising. We've got the 3 cycle loops. Now is when she starts by putting in an X. She puts in another X at the end of the first, at the start of the second and start of the third. She doesn't put one in the end because she's just getting it back. So that wouldn't make sense. So she's going to have this X for 3 years, this for 2, and this for 1. But look what's going to happen. When this X here gets multiplied by the 1.07, it becomes 1.07X. But she then adds another one. So at the end of the first year, the start of the second, she has 2.07X to invest. This 2.07X we'll leave for the moment. Okay? But all of it is going to be multiplied again. So 2.07 times 1.07 is 2.2149X. And that's what's happening to all of this. But that's not enough. What's she doing the next year? In addition to the 2.214, which she's got from this one, she's adding another x. So now she has a total of 3.2149x. It's not surprising that that's roughly 3. It's a bit more than 3. Because remember that she had 1x at the start of the first year, then 2, and then 3. And the reason it's not 3 but 3.2149x is because of all the interest she's picked up along the way. So she now has 3.2149x. For the final year, another 7%, and that becomes 3.433994x. So what she has is 3.43994x. But what do we want that to be? Well, Sorcha wants 100,000 euro. So this number here has to equal that. So what we get is we say that the 100,000 she was looking for has to be 3.439943x. X has to be 29,070. That's not bad, really. That probably seems a bit right. Let's say she wanted 100,000 after 3 years and she was willing to put in 3 amounts and there was no interest. Then it would be 33, 33 and 33, or 33 and a third. So 33, or she wanted 90,000, it would be 30, 30 and 30. But in this case you're looking at 100,000, so 33 and a third, 33.333 is what she'd have to put in each year if there was no interest. It looks like if she starts now, 29,070 will do it for her. Claude is the next person, and she's interested in interest rates, and she's put in €1,000 in a fund for 5 years. Now, in the first and the 5th year, the interest rate was 5%. During the intervening year, the money was put in a fixed account at a fixed rate. We don't know what it is. But the total at the end of 5 years was 138888. What happened in those 5 years, or in those intervening 3 years? So again, with these paragraphs, we just have to work out what are the hints that they're giving us. We work out the Sudoku. She invested 100,000. That's a number. In a fund for 5 years, that's a good number. In the first and the 5th, the interest rate was 5%. So R at some stage was 5%, just for one of the years, or the first and the 5th. During the intervening, we don't know. It was in a fixed account. What was the fixed rate if the total at the end? Oh, the total at the end were given. Okay. So we're given 1, 2, 3, 4 for 2 of the years, and something's missing. We don't know the rate in the years 2, 3, and 4. Let's see if we can draw this then. Well, what it's really saying is that we always start with now. We always finish with the end. So it's a 5 year, so this is now, and this is at the end of 5. €1,000 is put in now. And for the first year, after a year, we were told it's 1.05%. So it went to 1,050. After this, we don't really know what happened. It had some x here, multiplication by x, and we don't know what it is. But in the final version here, it moved up to 1388.88. Or before that, if that was 5%, this must have been 1322. We could work that out as well. So we're close, but not close enough. We know that 1050 was here, and this was moving at a certain rate. But we know that it was constant. The multiplier was always x. So really what we're saying is that this 1050 here, when it went through 1, 2, 3 loops, became 1322.74 with 3 x's. And we know that it's multiplication because we're moving from before to later. So what we're saying is that 1050 times x times x times x is 1322.74. Now we can simplify this. We can take that 150 to the other side. We don't like it. We divide by 1050. We divide by 1050. So we get x cubed is equal to whatever this number turns out to be. So what we find is that x cubed, when we do the calculation, turns out to be 1.259755. That's x cubed. But we're not interested in x cubed. X cubed is just the combination over the 3 years. So to get rid of the x cubed, we just take the cubic root. And if we take the cubic root of one side, we better take the cubic root of the other. So here, the cubic root of x cubed is that, and we take the cubic root, we find that x is equal to 1.08. Now that's interesting. 1.08. That means as we went from 1 year to the next, the compounding was 1.08. I was 1.08. But I is equal to 1 plus R percent. And that's equal to 1.08. R percent is equal to 0.08. Or, on its own, you'd have to multiply by 100, and that's equal to 8. R is equal to 8%. So what we actually found out is that if you take Claudine's particular investment, and we look back on it, that in this period here, as she was moving during that, between 5% and 5%, if we were to take 1.08 and work it through, we'd find that that's exactly what happened. So 1050 here times 1.08 cubed will give us 1322.74. So 8% was what she was earning. And that's the end of finance and tax. Thank you very much.